Hey guys, it's shortcut day. Welcome to your Unit 6 Lesson 2 notes on multiplying and dividing powers. Today I'm just going to show you some shortcuts that you can do when you multiply and divide. Yeah, that'll be great. So remember that a power is an expression where you have a base and an exponent. Here our base is 2 and our exponent is 1, etc. So what I'm going to do is I'm going to show you the trick with real numbers, and then I'm going to actually tell you what it is. So here we've got real actual numbers. We've got 2's, we've got powers of 2. So I'm going to have you I am going to rewrite an expression with powers. For example, if we have 4 times 2 equals 8, I'm going to keep the times and the equals, but I'm going to rewrite them as powers of 2. So it's 2 to some power times 2 to another power equals 2 to what power? Well, 4 is 2 squared. Okay? And 2 is 2 to the first power, and 8 is 2 cubed. This is because to get 4, you multiply 2 times 2, and to get 2, you just multiply once, so it's twice, once, and 8 then is 1, 2, 3, 2 cubed, because you multiply 3 2's together. So there you go. Now what pattern, so that's one way to write that as an expression of powers of 2. Let's do another one. So we'll follow that same pattern. We've got 2 to some power times 2 to another power equals 2 to whatever power. 4 is 2 squared. 8, you just saw, is 2 cubed. And 32 is 2 to the 5th power. Fun fact. Okay, let's do one more. We're going to write our last equation as a statement with powers of 2. So 16 is 2 to the 4th power. 8 is 2 cubed. And 128 is 2 to the 7th power. So what do you notice about the exponents? What patterns are the exponents taking? You have 2, 1, and 3. 2, 3 to 5. And 4 and 3 make 7. What do we do that? Well, that's addition. 2 plus 1 is 3. 2 plus 3 is 5. 4 plus 3, 7. So you just add the exponents together as long as we're multiplying the same base. And you guys, that's the whole lesson. That's the whole lesson in a nutshell. When you multiply, just add the exponents together. And I'm going to show you right now that it does work for any number. Let's say you have any number and you square it, okay? And you multiply that by the same number cubed, okay? And I claim, hey, since we're multiplying, you just have to take the 2 and the 3 and you add them up and you're going to get a to the 5th power. That's what I claim, and I'm going to show you that it's true. Okay, well, a squared, remember that's just the same thing as a times a. And a cubed, well, that's just the same thing as 1, 2, 3. Okay, well, now how many a's do I have? That's 5 a's. So that's a to the 5th power. Oh, hey, look. A to the 5th power is a to the 5th power. Nice. Okay, so here's your shortcut. I will write it. Let's say you have a to the mth power. Here a is our base. A to the mth power and m is one of our exponents. Okay, and you multiply that times a to the nth power. So n is another exponent here in our little equation. I claim that we just figured out that that is equal to a times m plus n. So as long as you're multiplying by the same number, you have the same base, the same number on bottom, all you do is you take your exponents and you add them together. Okay. Now, this comes in handy when we simplify expressions. So a simplified expression, excuse me, An expression that's simplified is when the base is only appears once, and fractions need to be in their simplest form as well. So you can't have any fraction exponents. I'm sorry, you don't. We're not going to have fraction exponents in this class, but you don't have any fractions like down here. Okay. So here we go. 10 to the 4th times 10 squared. Well, look, we have the same base. It's both 10 to something, and we have a multiplication. So remember, multiply means you add the exponents, our exponents here, 4 and 2. So that's equal to 10 to the 4 plus 2 with power, 4 plus second power. Anyway, 4 plus 2 is 6. So we get 10 to the 6th power. Sweet. Let's do it again. Here gets a little funky. We just need to look at numbers that are the same. So here we've got some coefficients. We've got some normal numbers. And then we have a squared and a... Oh, it doesn't have an exponent. Remember, it's a little 1 guy. Okay, so we're going to combine those together. That's the same thing as negative 3 times 5 times a, and then we're going to add those exponents together. 2 plus 1. Which gives us negative 15 times a cubed. Sweetums. Okay, we've got one more. Remember, we just need to combine all the same bases. So we put our s's together, we put our t's together, and that gives us s to the 5 plus 4th power times t to the 2 plus 6th power. So that's s to the 9th power times t to the 8th power. Super-de-duper. Okay, so that's multiplying. Sweet. What happens when we do the opposites? What happens when we divide? Well, let's track the exponents. I took the time to write them out for you. You're welcome. Okay, so again, we've still got powers of 2, but this time we've got dividing. 4, so to the 4th divided by 2 cubes equals 2. All right, and now we've got 5 to 2 makes 3, and then 6 to 1 makes 5. What's the pattern here? I'm going to show you. Just like multiplication is the opposite of division, addition is the opposite of subtraction, or addition? Yeah, addition is the opposite of subtraction. So instead of adding exponents together, we're going to subtract. Instead of multiplying, we're going to divide. Now, does this work for any number? I claim it does. Let's say we take literally any number, raise it to some power. I'm just going to pick 5 because it's fun. And we're going to divide by the same number squared. Why not? Okay. Remember that raised to the 5th power means you multiply it 5 times. Don't mind my awkward circle. 1, 2, 3, 4, 5. And then squared means it's twice. 1, 2. And dividing means dividing. Yay. Okay, well, that's kind of gross. Let's see if we can reduce that a little bit. This a reduces with that one. This a reduces with that one. And we're just left with 3 a's. So that's a times a times a. Cool. Well, according to our rule, we said that this is the same thing as a to the 5 minus 2th second, 5th minus 2nd power. A to the power of 5 minus 2. And is 5 minus 2 equal to 3? Oh, yes, it is. That's a cubed. Whoa, that's so cool. We nailed it. Okay, so to put that in kind of shorthand, when you're dividing, so if you have a to the mth power divided by a to the nth power, that's the same thing as a to the m minus nth power. So how do we simplify? This is also our key idea right here. How do we simplify expressions with exponents? Well, first, you need to put everything with the same base together. Remember, your base is your bottom number, the big number with the exponent. And then you need to actually do the dividing part. And then we subtract exponents when we divide. Okay, cool. Here, we already have just the one base. Cool. So we can rewrite that with subtracting our exponents. So that's the same thing as 8 to the 5 to the power of 5 minus 2. 5 minus 2 is 3. So that's 8 cubed. Yay! Next one. Here we need to split them up to have the same base. So here we group all the A's together, and then we'll group all the B's together. Okay, so that's the same thing as, there's two expressions. Oop. As A to the 4th power over A and B to the 3rd power over B squared. Now we can rewrite them as a subtraction problem. So this is the same thing as A to the 4 minus 1 to the power of 4 minus 1 times B to the power of 3 minus 2. 4 minus 1 is 3, and 3 minus 2 is 1. But remember, when you have something to the first power, you don't even need to write it. So you can just say, oh, hey, that's just A cubed times B. Done. Sweet. Let's do one more that's even more complicated. But guys, guess what? The good news is it's not really complicated. It's just the same step a couple more times. So as long as you can do one, you just keep doing the math over and over again. So first, let's group all of our normal numbers, our coefficients, together. And then we'll group our M's, as in mama, Mike. Our Mikes together. And then we will group our N, as in Novembers, together. Okay, so we've got negative 30 over 10 times M to the 5th over M cubed times N squared over N. We're going to just treat them all like their own individual problem. Let's start with yellow. Okay. Well, that's easy. What's negative 30 divided by 10? Negative 3. Cool. Next, we've got M to the, we need to subtract the powers. 5 minus 3. 5 minus 3. Oh, my hint for you. Here's your helpful little hint. You see this guy, the subtract? The dividing kind of looks like a subtract. So that's your hint to subtract exponents, because the division looks like subtraction. Okay, and then for our last guy, we've got N to the 2 subtractee line. Oh, remember this is like a 1. So 2 minus 1th power, 2 minus 1st power. I don't know, to the power of 2 minus 1. Math grammar is weird. Hey, we're almost there. Negative 3 is negative 3. M to the 5 minus 3 is 2. And N to the 2 minus 1 is 1. But you don't need an exponent of 1. You can just leave it all alone. Oh, hey, you don't need an exponent of 1? You can just leave it all alone? That's right. For any number, A to the first power is just A. That's just that number. So like 2 to the first power is 2. But what's even better is, let's say you get an exponent of 0. When your exponent is 0, that's just equal to 1. If you want me to prove it to you, I would love to prove it to you during class. Okay. So literally, this is true for any number. Any number to the 0th power, 1. 7 to the 0th power is 1. 5791 to the 0th power is 1. M to the 0th power, no matter what M is 1. Aha! But what if you have a number to the 1st power? Well, just cross it out. It's not really there. It's 2075. Boom. Great, huh? Hey, remember your special cases of exponents. Remember that dividing means subtracting because it looks like a subtracting. And then multiplication is adding because it's like a sideways adding. Anyway, hey, have a great time on your homework.